blinded. I'm seeing spots from that projector. Sweet.
You're live, so.
I'm live, and I think I'm talking. Cool. Okay, so today I'm going to talk about Cassandra at T-Mobile, and I'm going to probably end up walking in front of that repeatedly because I don't like standing still. So first, of course, legal disclaimer. You know, these are my opinions. I'm not talking T-Mobile's thing. We're going to talk about Casquatch a little bit, which is an open source project. It's Apache 2.0, you know, all the usual legal stuff. Okay, so kind of what I'm going to talk about. So first, I want to kind of baseline, set the stage. Since some people are for scalability, some people have more Cassandra, kind of want to set some things. Then just story time, going to talk about kind of what's going on, what's pretty pictures, tell you all about that. Then I'm going to get a little more technical, get into some more detail, and then I'll probably show a live demo, if that works, which are always fun experiences. Try that, and then Q&A. So, setting the stage. So, again, stories. It's more fun. I thought about bringing out like a blanket and some Ledger dolls and all that, then no, decided not to. Decided pretty pictures were enough. So T-Mobile, so there's a pretty magenta. So T-Mobile, fastest growing US wireless carrier. We're based out of Bellevue, headquarters technically in Victoria. So based on the recent numbers, about 80 million subscribers, we're up to 52,000 employees. And you're going to see lots of magenta. I like using a fun slide deck. I toned down the magenta. Usually I wear a magenta shirt, but somebody commented in a presentation that I had too much magenta. So I wore a black T-Mobile shirt, but don't worry, it's still T-Mobile. Cassandra, who knows about Cassandra? Okay, good, most of the group, excellent. But I'm still going to just real quick, it's important, it's kind of the core of the presentation of what it is. So it's a distributed NoSQL database, wide columns, consistency, those kind of fun things. It's the masterless architecture. It has tunable consistency, really redundant, resilient, high uptime, high availability, greatly scalable, all those fun things. DataStax. So DataStax, who knows who DataStax is? Less people. They will afterwards. For people on the stream, they probably won't, unfortunately. But so DataStax is the software company that's behind that, and they offer DataStax Enterprise, which is the modified version of Apache Cassandra. They're also one of the big contributors to Cassandra. And for us, where they come into the story is a lot for the enterprise support, and also some extra magic, which we'll get into the magic later. Then me, there's my picture. There's my LinkedIn and GitHub if you want to reach out and connect. So I work at T-Mobile, I'm principal engineer, and I lead the distributed data systems team. So we kind of do a databases as a service for T-Mobile engineering. So T-Mobile engineering is, you have like the internal IT, and that's an organization, but T-Mobile engineering is kind of the core, the network stuff. So you got your voice, you got your data, you got all those classic things that every telecom has. But these days, everyone's got these smartphones. Those smartphones require lots of little services and widgets. There's all those apps, and I'm not talking about all those pre-built apps you can't delete. When I mean widgets, I'm like the things to activate. You go out and buy an Apple Watch, and you say, okay, I want to activate T-Mobile LTE service on that. Those services, those are the things we build. So we're the internal software development group within that builds all those APIs and backends. And Apple Watch and many activations, basically any activation that isn't a phone, so tablets, hotspots, watches, all those kind of things, those are all backed by this Cassandra architecture. And also eSIMs. So eSIM started becoming more popular. It's a way to just kind of have a digital SIM. A lot of the new iPhones support it. It's becoming more of a thing, but those services all come through here as well. Cool, so now we're story time. So we're gonna kind of, again, go a little deeper, talk about here. I'm gonna talk about kind of where we went, how we got here, and touch on a few of the pain points, lessons learned as we go. So Oracle. Does everyone know what Oracle is? Thank you. I was actually at a presentation, and they're like, okay, who's ever used a database? And it was at Accelerate. And it was actually like 2 people. They're like, nope, never used SQL. Like, okay, it's possible, great. So when I started working with this team and this infrastructure, we're running exclusively on Oracle. They were single instance databases. For the most part, they were either just one-sided, or if they did have 2 sites, it's Golden Gate between them, active standby. That's where we were a while ago. Still love Oracle, still use a lot of Oracle, great. But we started looking at that infrastructure, and we started thinking about it of how it's going to scale. And we started looking at kind of the newer buzzwords of 5G and IoT, and this more rapid data that we started having to work on. So when we started looking at those and trying to think of, okay, what are our issues? One of our biggest issues was handling active everywhere. That when Golden Gate works really well for us, and it's the replication product to sync to Oracle databases. Even in an ideal situation, kind of what you can actually hope to target, ends up being about a 5 to 10 second latency delay when you're running across country. And if you're trying to go for an active real-time scenario, it works in some cases, and we have many apps that still do this, and you can do it by targeting. So this customer always goes to the West Coast, this one always over here, that kind of idea. So you can make it so you just kind of ignore the delay. Other ones we're doing more of an active standby. But we're trying to find a model that would allow us to do a database that you could point it anywhere, it'd be distributed, it'd be near real time and all that. The other big pain was failovers. So when you have these big vertical stacks, these big powerful servers, and there's your database, failing over between those data centers is a lot of work. So we wanted to kind of get rid of that. And at the time, we weren't doing any Oracle RAC. Now we are doing Oracle RAC. Oracle RAC is the clustering product, which gives you a lot of local redundancy. So today, we are using both. So they got together, there was a lot of planning, a lot of evaluation of different products, and ended up deciding to go with Cassandra. So that's where Cassandra comes in. This is great. So talked about it at a high level on paper, and as you're pitching it and looking at the high levels, it's great. It's always on. It's near real-time application. It's easy. It's globally distributed. It's fast. It's infinitely scalable. This is great. Yeah, well, the reality is somewhere lesser than that. Of course, there are great ways to do it, but you don't get that for free out of the box, of course. So, of course, we partnered with our great friends with DataStax. So this is where we started reaching out to DataStax to get our enterprise support. That if we're going to go into this new technology, we didn't want to do it alone. That we're learning it ourselves, so we kind of partnered to get a lot of those resourcing. And again, there's some of the advanced functionality that you get with their version of the product. Now, you're probably seeing this, and you're like, okay, it's this product, I just extract it, install it, very easy, so I'm going to put it up on the cloud, right? People like the cloud is easy. If you just want to say, great, I want these instances, you just click it, here I got 100 new instances, relatively fast once you have the credit card. So that's what most people are going to do. Unfortunately, for us, no cloud. Cloud is just a non-option. Just throw it out the window. We're not going to touch it. Everything's going to be bare metal hardware on-prem, which makes it a different scenario. You're not going to have these pre-baked images that are just in the marketplace. You click it, you deploy it, everything's easy. So we had to start looking at options and kind of understanding. So in order to do on-prem and this large distributed system with many nodes, you need a big pile of metal. A lot of servers. These are not our servers. They're just in our random image. Thought that was much safer. Even put it on a note there for when it did the legal review. But not only do I need one big pile of metal, and multiple big piles of metal, because I have multiple data centers. So every data center, I need all these servers. And in order to do that, we had to do a lot of capacity planning. Keep in mind that earlier I mentioned about this being this data as a service model. I have absolutely no idea what applications we're going to run on this thing when we started building it. We had no idea. They're not even invented. Most of our timelines are very, very, very shockingly short. I've had systems launches. We found out about it in the morning, and it launched nationally that night. That isn't common. but happened once. Usually they're a little longer, because a lot of those, coming back to what we do, a lot of those widgets, a lot of those are unreleased devices. That's very secretive. So most of the time I'm not going to know what's coming out. So I'm building a model here that's going to support some workload that I have no idea what that workload is. I have no idea when or any of that. So you have to build it this kind of general idea to get an idea. So capacity planning is fun, but we did it. We worked together, we figured out our plans, we designed this hardware, we worked with it, and then, again, unlike cloud, we had to submit it. So we get our specs, submit it to HP, I think it's HP, but whatever vendor it was procured from. You order the hardware, that's going to take some time. And then, procurement's going to negotiate it and go back and forth. Eventually, it's going to go, and then it's going to finally show up on site. And then somebody's got to install it. Somebody's got to design the network. Somebody's going to plug it all in. This took a long time. It takes a while to get physical hardware. It's not like just jumping in the cloud. But eventually, we had some servers. It's great. Finally had these servers. We could log in. I had an OS prompt. Let me talk about networking. So again, when you're running all this stuff on-prem, you're going to have to deal with your own models. So at T-Mobile, we've run into a few times that our network is a little special, especially when it came to Cassandra. And it's something that every time I explain our infrastructure, you kind of have to be like, wait, why is it this way? Why are you going through this routing? So at a high level, there's basically 3 networks they have to deal with. You got a public network. This is an extremely secure network. Many firewalls, very, very secure, which is great. But that's where only thing that's going to go over that is our application traffic. So that's the one that eventually is going to route through all the widgets, eventually going to be exposed to the actual customer, right? So your applications are there. That's where all your traffic is going. There's a private network. This is the easiest one. There's the one that's it's a dumb switch running on 192 or whatever. It's a little private network that's just running between the different nodes. And that's where you're going to build it right in. That's pretty common. Cassandra supports that really well. It's going to do replication on that. It's going to do its gossip on that. And if it happens to try to talk to a node that doesn't not on the same network, it just falls over to public. Easy. So that part works pretty well. The part that got weird and challenging is our third network. So our third network is not internet accessible. It's an internal network for management. And for most of our servers, this is where we have SSH access. So as an employee, if I want to access the service, I have to come in through the management network. I cannot come in through the public network because that's going to be blocked and routed only to those handsets or whatever, right? So for my work, I can't actually do it. So if I need to log into a server, if I need to use SQLSH or dbeaver or whatever to connect and troubleshoot with the database, that's a different network. So this was fairly painful to get working. We did eventually get it working. If you have a similar scenario, which you probably don't, I could talk to you about the details of the config. But basically what happens is in Cassandra, you have a broadcast address, which is going to be a public one. So that's the one all the nodes talk to, and they say, here's my main address. And you have listen addresses, and there's an RPC address, and this whole list of these different addresses we had to tweak and configure. So we got them all working. But the other part that we had to really get into is a product called Ops Center, which is a DataStax product for alerting and monitoring and management and lots of fun widgets. So our Ops Center servers, that's internal, so that's all over management. So those all needed access to the database over this network, even though when it looks at the node, all the nodes are broadcasting their public. They don't ever broadcast their management IP, so it got a bit weird. We got it mostly working. We had to submit some bugs. The bugs were fixed, and we were able to get it working and great. So all that, finally, get through all this, lots of fiddling, lots of tweaking of the addresses. Sorry, let me screwed up my slides.
What kind of bugs did you find?
Huh?
What kind of bugs?
Oh, sure. Yeah, so the main bug that we ran into is, so with Ops Center, there's a failover model. And the way it works is you got the Ops Center platform, and there's an agent that runs on the individual node, okay? So that agent is configured to talk to a certain Ops Center, and it's an active standby. So if there's a failover, it's got to reach out and reconfigure all those nodes. But the only address it originally knows about is your public address, which doesn't have SSH, so it can't log in, and the agent is running on the management. So there were some configuration values to get it to use a different address, and it worked for everything but failover. So it was the failovers that we were unable to do. So functionally, it was fine. I ran an Ansible script and reconfigured them after a failover. So it's not impacting, but it wasn't quite clean. That was the main thing we ran into. But yeah, it's because this isn't a common setup. So it wasn't really accounted for, so they fixed it, which was great. So finally, all that's set up, and I have a SQL prompt. This is not the real SQL prompt. It's running on my desktop, but it's a good image. So this is what the SQL prompt is, where you can actually log into your database, query it, interact with it. Great. I was so excited. And as part of our deal with DataStax, we had all these professional services hours. So I thought, hey, I've never done this before. Let me ask a professional. So I submitted my database for grading. That was fun. I didn't actually do too bad, which I was happy about. Most of my configuration was right. I had most of the settings correct. But apparently I had looked at some old documentation. So the one thing that I really did have to change is there's a concept of Cassandra called vnodes. At a quick level, so you got your cluster of, let's say, 10 nodes. If you set a virtual node, the idea is that instead of seeing 10 nodes and you set a vnodes of, say, 8, it treats it as if there's 80 nodes. And that helps with rebalancing. So that way, if you add a new node, instead of trying to take little pieces and break it all up, it's able to redirect tokens. So problem with that is very core to how the data is built in your structure. So what I found is to change the setting, all that work to get my database working, I had to delete everything and start over from scratch. Luckily, I automated it all, and we'll talk about the automation later. So it wasn't too bad, but this is one of the big pain points I've found, is that with Cassandra, a lot of your work, most of your work is getting it right at the beginning. Designing it, getting the design and all the effort there, so that operations, it's fine. But at the design, there's a lot of work you have to do, and this is not the first, not the last time that we have to gut our cluster and rebuild from scratch. I'm currently gutting my cluster again and rebuilding it from scratch, but doing it all live, no customer impact by moving nodes around. But when you get into these distributed systems with how they distribute the tokens and how they actually write that data across the cluster, a lot of that is fundamental baked into it, so that there are some settings, not a lot, but there are a few different things that if you need to change them, the only way to handle it is gut the whole thing and start over, and then reload your data. Yeah?
What other databases did you consider before you picked Cassandra?
Good question. That was actually before I started. So I know they considered we've talked about Couchbase. I believe Mongo was something that was talked about as well. But when I joined, it was after those talks. So unfortunately, I don't know specifically. I wasn't in the room. But yeah. Cool. So I submitted it, got it back. Great. So I made these changes. I gutted my cluster. Luckily, it was just me playing. I had no applications in it. So I rebuilt it all. I got a prompt again. I was so excited, because now I have a prompt. I passed my grading. I have a running cluster. This is wonderful. I was so excited. Thought I'd never have to rebuild it again. And I was wrong. OK. So next, now I got a cluster. Now I'm going to let my developers start playing with it. So Spring. Spring is a framework for Java that we use quite heavily. We use it for most of our applications. So now that we have a database, we're going to let them start playing with it. And one of the components of Spring is there's Spring and then Spring Boot's on top of it that kind of automates a lot of it. Spring Boot is more of what they're using, but there's another thing called Spring Data. And Spring Data is kind of a general framework for working with lots of data systems. So of course, there's Spring Data with Oracle, there's Spring Data with MySQL, I think. There's lots of different ones. There's a Spring Data Cassandra. But since it's a NoSQL system, it's different. And with relational databases, a lot of it is pretty similar, how you're going to interact with the different databases. But with NoSQL systems, you need to fit the use cases. You need to know a bit more than just basic queries. You need to model it properly. You need to do it specifically. So unfortunately, when you use a really generic platform like this, there's some differences. So the other thing with Spring is that it's this Spring Boot specifically, they call it convention over configuration. So the idea is, I thought the best way that was explained to me, I saw this graphic once, that Spring is like the ingredients. So that's got your flour, your sugar, your egg, your milk, all the different components for a cake. Spring Boot is the cake. It's all made for you. So instead of saying, Josh, here's how you're going to make a cake, here's a recipe, do all this thing, you just say, Josh, give me a cake. So I hand you a cake. That's Spring Boot. And instead you want to be, I want a chocolate cake. Okay, well you only had to tell me one change, otherwise I assume all these other things that make you a cake. There you go. So it makes it really generic for you, which is really powerful, but as long as those defaults are what you wanted them to be. So let's see, okay, let's review. We got Cassandra, we got Spring, we have happy developers dancing in pools of money. And I'm done, right? No, of course not. Never gonna be that easy. So everything did look great. And that's when we ran into our next real roadblock. We actually had launch services on this. And we thought everything was beautiful and happy and wonderful, and everyone was telling me how amazing it was to work with this Spring Data and Cassandra. And they didn't need to come to any of my trainings. They didn't need to know anything about Cassandra because they just used Spring Data Cassandra and they put their annotations and it worked beautifully and everything was great. So Spring Data Cassandra, again, is that model of, it's built for all the databases. It's not specifically for Cassandra. So some of the major pain points of kind of where it's not tuned right is that, one, it accepts all the defaults. There's a lot of default configuration that if you go Google and look at it, and now there's great documentation telling you, there's a lot of things you want to change from all the default settings. And they've improved a lot of those in newer versions, but at the time, there were a lot of defaults that needed to be changed. And also with Cassandra, there's a concept called a tombstone. Real quick, what a tombstone is, basically at the underlying data, everything's more or less being stored, very heavily abstracted, but basically it's a key value pair being stored there, right? So in a traditional relational database, you got your row of data. If you don't put a field or you put a null, it doesn't matter because it's still your row of data. It takes that space. But with Cassandra, since everything's broken out in key values, you put a null, a non-value, actually creates a key value where the value is null. If you get too many of those, then you've overdone your data. You have all these extra things, all these tombstones that are wasted, inefficient. You can only handle so many. You've got to parse all these blanks. Very negative. They went back and forth with a lot of versions. I checked recently, the newest version, they came up with a really simple way to handle tombstones, which I thought was cool. What Spring Data did now is that they made it so on inserts, if there's a null on the insert, then it's going to persist the null. If it's an update, it doesn't do the tombstone thing. Now I said those backwards. I'm sorry. Other way around. Updates when you want the tombstones because you're clearing out the data. Sorry. So opposite. So in the insert, it doesn't persist because you don't need those values. It's not there. You just don't populate them. Update it sets it to null. So it's very clean in that way that, okay, one API works one way, the other API works a different way. At the time, I found that they kept switching. Different minor versions, someone would submit a ticket and say, great, don't persist nulls, it's bad with Cassandra. Okay, I'll fix it. And then someone else did it the other way, and there are too many opinions, so it got really complicated. So tombstones were a problem. The other big thing is batches. So in your classic relational database, you have your transactions. In NoSQL, with Cassandra, it does support batches, but they're not, there are some use cases, there are reasons you want to use them, but it's a much simpler answer, just don't use them. They're not good, there's some performance concerns, there's a lot more complexity to it, but because it's trying to build up a transactional model that's really generic, it's like, here's the API that does the batching, here's the API that kind of works with this, great, let's use it. So heavy use of batching. And then also just the way it was scanning, there's some inefficiencies there. So I ended up building a thing called Casquatch. I'm going to come back to it at the end, but to all solve this, built our own custom framework that's going to handle most of these issues. Training. There's a happy little professor at the chalkboard. I'm going to talk about this a few times throughout my chat because training is really important. It was the most important part of us for us because people were coming with a relational database background. There's a lot of assumptions there. When you're coming into a non-SQL, you can't just put everything in that database. You need to have the right use cases. You need to think about how you're modeling. There's a lot more planning at the design stage for efficiency. And that's hard. When you don't have that background, you can't just jump into it. They're not teaching this at school in the same way, and there's so many NoSQL databases, you can't just take, I know this one, I guess I can use all the rest of them. It's very different. So there's a lot of training here. What I thought was really interesting, though, with the training was the people who loved Cassandra the most were also the brand new developers. Because when they're coming fresh out of school, they don't have all that baggage. They don't have all this background of, I've been coding against Oracle for 10 years. Why didn't it roll back my data when I canceled the transaction? Obviously, a database does that because I didn't commit or whatever, right? So there's all these assumptions that you've been using a database for so long, you just assume. But when you don't have any assumptions, you're like, oh, that's what it does, great. That's awesome, I don't need to worry about this. I can just believe you, everything is great. So that was interesting, because most of our people had been using it for a while, but we did get a bunch of newer developers, and a lot of them had easier time adapting. So again, training, more training, lots of training. Training is important. The other big part of where we did training is where we brought in a lot of DataStax resources, and John is here from DataStax, who helped pull in a lot of those resources for us, helped us do a lot of workshops. So we did a lot of repetitive ones, internal, external, tell people again and again, and eventually it will sink in. We did fundamentals, where we started from nothing, did some advanced ones, did some really advanced ones, and kind of broke out these different ones, and we'll talk about training again more later. But our biggest success with training was actually finding, since we're this database as a service kind of model, we got a lot of application teams out there using our products. And within those app teams, when we were able to find that one person who wanted to know more, they're the person who would stay late, they'd come to every training, they'd come to my desk and ask more questions. They wanted to know about the internals. How is it stored? Where's my replica? What is it doing? What is the call flow? Awesome. When I could find that person, those were the apps that are running beautifully on Cassandra, because they were able to get that one developer that's actually in the team, and they were able to start speaking at their stand-ups and explain, no, here's why we can't do that crazy idea. Because when it's here, if you work with Cassandra, then this works better. Or what was great also when they were also the developer, they're just like, don't worry, I'll write all the Cassandra code. And I'll just do it, I love this is great. So those really helped us to really get over that burden. And that, again, that was generally the people who hadn't really been using other systems, that they just loved it. It worked great for them. So now I'm going to talk a little bit about our actual environment and some of the specifics that we had to think about. So, components. So there are three main components that we want to talk about. So as part of the DataStax Enterprise, there's these additional ones. But here's our Cassandra. That's your core Cassandra, core to the product. Of course, DataStax has some extra magic on top. It's not exactly the open source. But for the purposes of this, you got your Cassandra, your traffic. We're putting all our reads and writes there. Then there's two other components. There's a Solr component. Solr is going to give you searching and indexing. And there's some caveats and things to consider there. And then Spark. Spark is for our analytics. Spark is used in many other places, but basically running distributed processing. It does some really cool things, though, that I thought was great about the integration, is that basically it's able to account for data locality, so that when you distribute it to the nodes, it's only going to look at the data that's on that one specific Cassandra node. And that way it's able to just use the local SSD, and it can be really fast and efficient and kind of distribute it in that way, which is great. But we split them out. We put them each, even though one physical data center has all these components, we split them into logical data centers. So that way all our traffic was kind of segregated between the three different types of workloads. Now, I obviously have more than one data center, so I need more than one set. So this way every data center has all three components. You got the traffic, you got the Solr, and you got the Spark. Now, within those, there's this concept of a replication factor. So the replication factor is basically it's how many copies you have. And you can define it per key space, which is the set of tables and all that. So in our case, basically per application. And also per data center, per logical data center even. So I can say, I want 3 copies in the Cassandra, I want 1 in Solr, I want 1 in Spark, whatever. But every place you do it, that's another copy of our data. The really simple, easy best practice, generally, you got 3, replication factor of 3. And then the other place that comes into play, there's something called a consistency level. And consistency level, there's a bunch of different options, but basically it says on a read and a write, how many replicas am I going to look at? So commonly, you're going to use local corn, which says, okay, look at this one data center, and give me the majority. So if you're using 3 copies, 2 out of 3 from the local data center, now I know I've got it. So that is true for Cassandra. We initially thought it was true for everything. Where we ran into some issues there is that with Solr, the way Solr works, it's an indexing engine, uses Lucene indexes on top of it. But when I run my query, it looks like any other query if I'm using that interface. But behind the scenes, it's always going to be a local 1. So if I've got 3 copies, and one of those happens to be out of sync, I'm going to get some inconsistent data. So it's something we had to consider. So that's where it came into this concept of availability versus consistency that we had to consider. So jumping in a lot of terms through it, but there's this concept in distributed systems called the CAP theorem. And the 30-second explanation of CAP, you got consistency, availability, partition tolerance. You can only have 2. So you have to kind of weigh a balance. And partition tolerance is great. So if you have your network breaks down between your nodes, can you handle that? Can you recover? Consistency is if I write my data and I'm going to read that data, will it be the same data? Is it guaranteed to be the same? And then availability is just if I ask you for data, you're going to respond, right? So in most systems, networks suck. They're going to break, especially when you're doing data centers across the country. You're going to have issues. So the P is a given. You have to have that, or else you're just going to be always breaking, right? So you're really here balancing between your consistency and availability. So this really hit us when we were looking at Solr and trying to figure out ways to do Solr. So what we found was that Solr is great for some use cases, and it's not so great for other use cases. If you actually look at the Apache Solr page, and for the core project, it even warns you, don't use this as a core data source. It's a best effort technology. It's not a guaranteed technology. So it allows you to do all this complex indexing and searching on top of your Cassandra data, which is great. But it works really well. The best one that I've heard of is, so let's use your online search engine, retail store, whatever, right? And you got to search for something. You search for light bulbs. Great. So you're on Amazon, you type in light bulb, get a bunch of light bulbs. If there's 1 million light bulbs for different vendors selling light bulbs, if you get 90% of them, you don't care that you lost 10% of your data. It's more or less fine, right? So it's best ever, it's great there. But instead, let's say we're doing the accounting side of that. We want to know how many light bulbs we sold so that we can pay our vendors for those light bulbs we just sold. Now missing 1 is a serious problem. You need true consistent data. Yeah?
Cassandra itself provides indexing. Why did you have to use Solr?
Are you referring to the secondary indexing?
Yeah.
So there's a lot of issues with secondary indexing, and it's generally considered not a good practice to use it. And you can get into the details about that, but the way that it's storing it, it's not very efficient. It's something that is actively being worked on and fixed. And if you go look at the documentation on it, there are some changes that are expected, but it's not a very reliable, good solution here. There's definitely a lot of pain points there.
Is your data time series kind of thing? Is your data time series kind of thing?
No, not for the most part. So generally, a lot of these are going to be, our most common use case for Solr that we're doing is the ones that work really well are when they say, great, I need Solr. My app doesn't need Solr, but me as an administrator need Solr. So you got your table with all your properly modeled data that's keyed off some unique primary key that's always in my transactions. Great. Everything's going to be speedy and fast. But as an administrator, I need to go query it by random arbitrary things because I'm troubleshooting, I'm doing operations. So those are the people that love Solr, because they can do these ad hoc things. I can query by any field. I don't care if it took 30 seconds to get the query or a minute or whatever, because I'm the administrator trying to interact with it. Those use cases, my people really like Solr. Yeah.
If you can throw some light on how your data looks like and how you went about modeling your data in Cassandra at some point.
That's too specific and confidential to the actual data structures of the actual applications. A lot of them, but I can say at a high level, that for the most part, the ones that work really well are going to be ones that are keying off a unique identifier and getting an object. So you're going to be tied off a UID for the individual one, or there's different identifiers for the devices, that a lot of those application use cases are keying their set of data off that unique ID, and those are going to be really fast. And that way we're able to also target and keep a whole transaction of that same ID, target to the same application server and interact with it that way. So those models work really well. There are other ones that get more complicated and have other models around it. So there are definitely other use cases we do it, but I unfortunately can't share specific schemas. So I'm mainly talking about the architecture and that level.
Can you share who was the most impacted by that lack of accuracy in the?
It's a billing use case.
It was mostly the billing and accounting.
Yep, a reconciliation use case. That's the one where, because with most financial ones, end of the month, quarter, whatever, you're going to say, okay, vendor A, I owe you X. And then we respond, no, we owe you Y. You got to figure out the delta and figure out why it's different, that kind of idea, right? So that when you're trying to do these large batches out of Solr, that's when we're finding some inconsistencies, and we had to start tuning this replication factor. And that is, I think, yeah, it was on this one, that kind of where I started thinking was, originally I had in Solr, was like, okay, well, if it's a local one, and I don't want to keep all these extra copies of my data, I just stored one copy. Thinking, great, that way I've got consistency, because it's always going to be the one copy. However, if I'm writing all my traffic over here, and that replication fails, because it's asynchronously written to that logical data center, if that fails, until you are running repair processes, but those generally you target about 9 days as a full repair. So worst case, it takes 9 days to guarantee that it's there. But there's other ways it gets repaired, whatever. But when you're running these and you're running it, say, next day to give me all the transactions for the previous day, there are possibilities of data getting missing. So we ended up deciding that for those use cases, it was better to have 3 replicas, and that the data, it would be better to get stale data than missing data. Because that way it's very likely at least one of those replicas is there, even if I updated it. So it's kind of, you're having to balance it. So you have to even choose, look at the individual use case of what is more desirable. So on the other hand, like my ones that are troubleshooting, that example, right?
Yeah.
A lot of that's log data. I don't want to store 3 copies in all of these logical DCs and physical DCs of all my log data. That's a lot of extra rows. That's a lot of wasted data, and these are running on local SSDs. It's very expensive. So those ones I'm able to just do 1 copy. Because it's like, okay, you're going to query a log. This isn't, if you're missing a row, that doesn't break anything. The customer is not going to fail services, right? So you do have to kind of balance it for that specific use case.
Did business have to change their expectations based on this? Like that you might have stale data, perhaps?
That comes into one of the, it's eventually consistent. It is an eventually consistent database. So yeah, that is something that you do when you're at those initial conversations of deciding which database to do. You do need to bring that into account. You do need to consider, can I handle eventual consistency? Often, yes. A lot of use cases that's theoretically stale data. Generally, it is going to be consistent, but it depends on how fast you're doing it. But if you're reading from West Coast and then a millisecond later reading from East Coast, no technology is going to have those in sync. That's impossible to run across the country at that speed, right? So you have to look at those use cases and understand those flows. And you can improve that by, let's say, if you do know you have that immediately read and write use case, you target the same data center. So you target that device of, no, this device, I'm going to keep cookies in that session and make it so when that device, that one always goes to the West Coast data center. So you do have to architect that and decide exactly how you want to route that to handle those scenarios.
Yeah, kind of looking at this slide, it's a balance you got to kind of make a
Yeah.
decision on. It really comes down to, do you want consistent? Well, then you're going to give up something for it. So
Yep.
you can, with Cassandra, do consistency. You do quorum reads, quorum writes, you got consistent data. But then your availability is going to change. You're going to be impacted.
Yep.
That's all.
And that's the point.
I'm just thinking from the business side of things. If you're serving a business consumer that says, I'm going to charge people money for
Yep.
products, and I want full 100% accountability for that, do you then change their expectations and say, well, I'll give you this list today that you bill, and then have a grace period of 3 days, and in 3 days, some eventual consistency will
So-
appear and
Yeah,
coalesce,
those really get
and you
in.
can
But we're-
finalize.
There's many ways to
We're
do it.
talking in
Yeah,
milliseconds, not in
eventually,
days.
it's
So-
still fast.
Well, I heard like a 9-day.
That's for the
Oh,
repair,
no, no,
because if a query does fail.
Yeah, what it is you're running a repair that, yeah, you could shorten that cycle, but you're not getting really advantages of the anti-entropy
So,
capabilities that that's doing.
I think
Instead, but that's a different concept than
Yeah,
what we're
to
discussing.
clarify where the delay was, is to fix if there were failure.
Yeah.
So let's say there was a the packets were lost because there was an asynchronous call. So those shouldn't be very common, but is possible that those fail, and if it failed to get to that specific node, so it failed to get into the index, there's a constant process that's constantly making sure the data is in sync. That's where there would be a delay. So it is immediately asynchronously sent to the node, so it should be there, but if there were failures, accounting for those failures, you're kind of fixing it, and that's where there could be some delays. But most of the time that doesn't come into play, but it does when you're looking at, very large set and you're upset like there's a couple rows missing. Well, it's still very high durability, like a very high percentage was successful, but it does come into play. Yes?
Follow up to that. Did you ever find out why Solar was using local one in the first place? Like,
That's by design.
why is that?
So the way it basically works is it's Lucene indexes on top of Cassandra. And what it's doing is it's indexing by all the different things, so you can decide what fields and whatever. But it's taking those fields and indexing it based on the document ID, which is basically your primary key. Okay? So it uses all the indexes, uses its logic to pull them all together, decide here's my list of document IDs. And then it basically iterates over those document IDs, running select queries against the underlying Cassandra database, and it's using a local one for that query. And that's just by design. That's how it was written and implemented.
Is that not something we could have fixed by just asking the bug report to them, say, go fix it, so that we can get a report to quorum or something? Or is that like?
Yeah, but I don't know if you want to do that per se.
Because if you also come back to the earlier comment that solar as a core technology is not defined to be a true guaranteed data source.
Yeah, it's not meant to be transactional per se.
Yeah.
So you're okay with, I'm reading data.
It's for a big set of data. If I have millions, tens of millions, hundreds of millions of rows, and I'm, again, coming back to that like retail example, right? Where you're saying, okay, well, if I miss some small percentage, it still fits the use case properly.
Yeah.
So I tell my people, use it as a best effort. It should be mostly true, but don't use it in the billing use cases. I prefer, if I want the more guarantee, I'm going to use Spark.
Yeah.
In your research, did you ever find any other search, like Elastic, for example? Did you feel that was more reliable than Solar?
I didn't do the comparisons. The reason I'm using Solar is a baked-in component of DataStax Enterprise.
Yeah.
So that's why, that's what it was there. Yeah, there is like a Alessandra project that puts Elastic. I haven't played with it myself.
Do you allow schema lists?
What's that? What do you?
That people, it's a database as a service, so can an application just start storing whatever they want? Or do you ask them to go through a schema process so you know what they're storing?
So we do need to create the tables for them. I'm going to show in a couple slides actually talk about that process a little bit, but technically, yes, they can build whatever they want. I don't block them. I give strong opinions and advice, but I don't necessarily block them.
And
If
then
that's what you're asking.
if people are doing BI on like Tableau, they need to know some schema. Do you use things like Lucidchart or some way to do schema discovery?
Yeah, we're not using Tableau or any BI tools like that against this cluster. This is purely transactional. If it's going to go to BI or something, that's going to be an export to a BI system and sending through a data warehouse and all that.
Can you say what you use for the warehouse? It's okay if you can. Like if
It's
Oracle.
unfortunately complex answer because there's multiple groups and it depends what part of business was requesting it. There are multiple ones. So generally what we're getting is this business unit that is more or less the owner of that data is saying, okay guys, give me an export of this data, put it in the share, we're going to consume it. So the actual, what they end up doing with it is kind of, we're not involved there. So it's not, we're more on the transactional actual applications.
This is a transactional store, right? Not
Yes.
a transactional processor.
Yes,
Yeah.
so we're not doing the analytics with it now.
Or you're not doing LLTP where you have locking and all that, and ACID compliance. So this is more of a store.
Yeah, so,
storage tool.
I mean, it is used in the transactions. The applications are directly working with it, but yeah, you're not, I mean, this kind of system isn't ACID compliant. It's not. We do have applications that require that, and again, that's where we still do have a lot of Oracle databases. So we evaluate which is the appropriate. This is going to get us really fast response times, but you are doing some trade-offs to get those response times.
And do you run this on a hypervisor? You mentioned you're in bare metal. Are you
Bare
truly
metal.
bare, or you run
True bare metal.
no VMware or anything?
Nope. No virtualization at all. Local SSDs, locally bare metal hardware. Yep. Cool. So this next one I touched on earlier, but I want to reiterate it. So we do a model it's multi-tenant. So there's a concept, there's multi-instance and multi-tenant. Multi-instance is where you say, okay, I got this big vertical powerful server, and I'm going to run 3 different Cassandra clusters all using the same node. But then you're going to have contention, you're going to have issues, and we're trying to avoid that. We're using a multi-tenant model. So we're able to find that when we load tested the hardware, it's at some large number of TPS, right? My applications need nowhere near that. So instead I'm building these larger clusters, and I'm giving an application a key space in that cluster, and I'm tracking it as more as a whole. Because a lot of my use cases, being that some of it are proof of concepts, it's like, okay, well, today I need 100 TPS, tomorrow 1,000, but eventually it could be 200 million users, not TPS, but it could be tens of thousands of TPS, right? And they don't know, is it going to actually take off? We don't know if we launch this new service, are we going to sell 100 million of that device and all of a sudden, great, everyone's wearing this new thing, or whatever, right? So they need to be able to scale for it, but they're not likely, not everything is going to use that. So when we had dedicated clusters, you end up having to buy all the hardware for that theoretical use case. Because again, it's all on-prem instead of cloud, you can't easily scale it in the same way. So we're using this multi-tenant, so we're tracking it as, here's kind of what they're using. Okay, I know if I add all these applications up, I'm using X TPS. I know my limits up here. I'm going to start worrying when I get to about 50%, but currently I'm far below that. So I know what my limits are, and I'm tracking it at a high level, which allows me to very rapidly deploy new applications and know that they can spike. That if they want this load, that overhead is there, and I'm able to let that be shared and quickly available for everyone. So it really starts reducing the cost. That if I have these smaller, especially proof of concept, some IoT device, some kind of new thing that's coming out that might just be something new that may or may not take off, I'm not going to deploy them a whole cluster, bare metal hardware, multiple data centers. At minimum, you're talking 6 physical servers. That's a lot. and all the work to get that going. So here I'm able to run this cluster and say, okay, well, I'm predicting over the next year, based on the load, I'm going to need 5 new servers next year, or whatever, right? So I'm able to pre-allocate that and just kind of track my high-level capacity. And the multi-tenant model helps a lot with that. Cool. Training. Actually, I was going to talk more, but I've talked about it a lot already. Again, training is very important, and that's all I want to stress kind of with this is that you have the core technologies, but then also depends, if you're doing the data modeling, coming back to your question here, if you're really involved with the data modeling, you might not need as much training here. But in our case, our developers are doing most of the data modeling on their own, and they might ask for feedback. So data modeling training and then best practices, kind of making sure they're doing it. Eventually for us, what we found worked really well is we started doing it in office hours. So we kind of let people come by, ask any questions, kind of get that feedback. Ansible. So I'm definitely nearing the end. I know it's a lot of content, but hopefully it's interesting. So Ansible is this technology we use for this kind of server orchestration. There's a lot of automation. I tell people that in theory, anything you're doing with shell scripts today, you could probably do in Ansible. It's going to be much cleaner, much more reusable, very portable. It's great. We love it. So we use it for our configuration management of all the different things. We use it for our deploying, and then I also actually use it for monitoring and alerting. Process that all my servers logs in every 5 minutes, does some health checks, and if anything goes down, if you randomly hit the power button on any of my servers, one of my guys will get a phone call within 5 minutes, which is pretty helpful. So Ansible's pretty extensible. It's backed by this. Cassandra's built out enough that we want to try this new, we were playing with this new virtual environment. But hey, let me just throw Cassandra on it and load test it. All I had to do was configure like 4 or 5 variables, run the script, there's my new cluster, ran my load test. Okay, that's not going to work. Let me just go on with my day. As opposed to if I was doing it all manually, it would have been that weeks of effort. Very helpful for us. And the next big one we also use Jenkins. So again, coming back to that data model, we found a situation where data models, like data, are eventually consistent. So if you're used to working with, say, Oracle or another relational database, you add a column, it's immediately available everywhere. It really shocked me the first time I added a column and then it was missing. I'm like, but I just added it, and it showed up a little bit later. It's like, oh right, it's all data. It's eventually consistent. So that ran into some issues with us, especially as we do have developers doing their own schema changes. So we built Jenkins around it. And what I did here is basically I said, okay, I'm not going to get in your way. I'm not going to stop you from running your SQL scripts. So basically, I run all my health checks, run whatever script they were doing, run more health checks. If it's production, there's a little approval step where I have to hit a button before it runs their script. Pretty helpful for us. We also use it so that allows them to do new key spaces, data fixes, SQL changes, but a lot of flexibility there. Architecture, so this kind of give you, at a generic answer, what we're doing. It's microservices. Some of these are in Docker, some of them are in VMs, kind of varies. But basically, you got your load balancers, you got your global load balancers, your local load balancers, all that. Whatever way is going to be filtering that traffic into you. Then there's a number of services. Could be one service for some of the smaller ones, or when they're actually embracing microservices and having tons of services, generally they're all talking to each other. Then eventually that ends up being a DAO service. So that's our data access object. And that's the only one that actually talks to the database. All of these will likely have multiple instances, of course. But that's the one that actually talks to the database itself. So it gives you kind of an idea of where that fits in. So we kind of filter all that traffic and you can bring it in there. Skip the rest of that I was going to talk there. And then Casquatch. So Casquatch is what we're generally running on that DAO. It's backing all these projects. I've open sourced it. I've written it, and it's up on GitHub if you want to check it out. But basically, it's a Java-based abstraction layer for Cassandra. It's going to allow you to do a lot of flexibility. It does failovers for you. You're able to configure retries. It'll build out all your APIs. If you really want to trust me with annotations, it'll completely build you a complete API access with REST for all the calls, and all you gave it was a little Java object. You gave it an annotation. It'll build everything for you. It's pretty fun. And kind of where that fits within the stack, you got your customer coming in. You got your Java application, then you got the Casquatch layer. So here's where you're going to have your Pojo, your Java object. That's going to have some query mapping. It's going to actually map it to SQL objects. Then you got the DataStax driver that's wrapping around. That's how it's actually going to interact with the database itself. And then Cassandra behind it. And that is, it is running off the open source one. So you could run this against Apache Cassandra just as much as you could DataStax Enterprise. It'll run against any of them. And I tested against all the public final releases. Cool. I was planning to do a demo on there. If people are interested in seeing a demo of that. I know it's been a lot of talking, but this is getting to the end. Cool. See at least one nodding, so I'll show you a quick demo. Because live demo is always fun. And you hope they work. And the arbitrary stuff doesn't also show up on the page. Okay. So I'm just going to run this really quick demo. This is available on the Casquatch page. And that shows up. Cool. And I do need the two windows because I'm going to end up with IntelliJ on the side. Cool. So the way the Spring tutorial works, so what I'm going to actually build here is I'm going to take from nothing, going to spin up Cassandra and Docker, going to build a data model, going to build the Pojo, going to spin up a full REST API with Swagger, fully running everything. And it should take like 5 minutes or less. Cool. So with Spring's that core with Spring Boot, it has this cool thing called Spring Initializer. What this is going to do is going to build out your basic project, kind of get you started, get you the easy bits. So we go through there. You're going to do a Maven project, just default version, who cares? Here's the name of my package. I'm naming it Spring REST. That's the demo. And then the only thing I'm adding is Spring Web. So that's going to let me do REST APIs. So we'll go ahead and generate that. Of course, I have no internet. Cool. Well, I already have a copy downloaded. So that's fine. That's perfectly fine. So we'll go over to our demo, our shell. Okay. We're going to make a new directory, or we can just do zip cut Spring. Cool. So this is just that same thing that I would have downloaded if I had internet. Cool. So we're going to go to Spring REST. Here's our project. And now if we go back to the tutorial, there's some junk that I delete because it's a lot of mess that they give you that you don't really need. I mean, it's great. It's a demo. It helps stuff. But I don't need most of that. Cool. So now I'm going to go ahead and open up my IntelliJ. I'm going to new project from sources. So we're going to go ahead and open up that project we just extracted. Temp, Spring REST, open a project. We're just going to accept all the defaults. Going to go in new window. Cool. Is that cool? That's more or less should be readable. Cool. And then we're going to bring you to the desktop. Yay, that's exactly what I wanted to show you. Okay, cool. So there's our project. This is just we're gonna bring up based on Docker. This is the public Apache Cassandra latest version. And we're gonna kill the one that I was demoing with my trial earlier. Cool. So now nothing's running. We're just gonna bring up brand new, running. It'll take a moment to spin that up. So now with that, I'm going to see if it is up. Cool. I have a running cluster, a running node. So all I'm doing here is I'm just logging over Docker. I'm going to create a new key space. So that's where I'm going to put all my stuff, and I'm going to create a table. So that's just a basic little table. I like to call my demo tables table name because I'm creative. It has two keys, key 1 and key 2, two columns, column 1 and column 2. Extremely basic, boring demo table.
That's a SQL shell?
Yep, so what this is doing is Docker exec, going to give it the name of the image container. CQLSH is basically just the SQL prompt. And then I'm just bringing in that SQL. Cool. Great, so now I got my database. Now I'm going to bring in Casquatch as a dependency to this new project I just downloaded. And so this is just I put the version number in a variable, and here are my two dependencies. I have the main Casquatch and then a test project. So that way you can have access to the test libraries as well. Not actually going to use them, but good practice to have your test libraries available. And then there's also this plugin. So Java has this thing called annotation processing. Basically, it's able to look at annotations on the code and generate code for you, which is very helpful. And I use heavily in Casquatch. Great. So I put in those dependencies. I'm going to tell Maven to re-import and scan all that. The next thing I need to do is I need to configure and tell my application how to connect to my database. By default, there's no authentication. Of course, you should use authentication in the real world, but we don't need that for our demo. So all you need to specify there is name, the IP address, in this case, localhost, name of the key space that I made over here, Spring Rest, and then the name of the data center, which is data center 1. And that's just what Docker is doing by default. Cool. So now we know how to connect. So now we're going to create our object. So we're going to give it a new class. We're going to call it table name so that it matches the name of our table. We're going to copy and paste this. So this is just a standard Java object to hold our data. It's going to mirror our table with the same types. So we have key 1, key 2, column 1, column 2. And I'm just going to click through and let it bring all those imports. Cool. There's also a couple annotations here. So labeling what the keys are. Those are my primary keys, so it's able to do them. And then my main annotation here, Casquatch entity. That's how I'm going to key into this object so that I know to build all the APIs for you. Cool. And then finally, I go back to our main object, and I'm going to tell it to generate all the APIs. So that line there tells it to find all the Casquatch entities and build a complete REST API service for you. Cool. And then I'm going to run it to make sure it runs. Fantastic. So let's test it. So now I have a full REST API for my database based on that object. It's going to connect to that database. It's going to give you all your gets, your saves, your deletes, whatever you want. Here's an example of calling it over curl. If you just want to use that to call your local REST API. And of course, I must have mistyped something. Thanks, demo. Oh, because it crashed. Must have another copy run. Sorry. Yep. Let's try that again. It's just an error saying I already have it. I'm already using that port in another window. That's all that was. So now it's going to run again. OK. There you go. Now you're being nice and friendly. So what I did here is, so I did a post to the endpoint, which is my table/save, gave it a JSON representation of that table. I'm going to bring up Swagger in a minute. That's going to make it look even prettier. But just to show you, it is running. So to bring in Swagger, so Swagger is a way that is going to give us some much more visual, easy. So again, putting that property up there. Oops. Putting in Swagger. So this is going to give me my Swagger and Swagger UI. And you'll see what that is in a minute if you haven't used them. Now I need to go back to my main project. Always need to re-import after I change my dependencies. Cool. There's my import. And then the final thing is this is a little widget that is to configure Swagger. So that's just telling it where to look for it, and that's going to help me bring up that. So we're just going to copy that. Cool. And now we're going to kill what I was doing. So we don't want you anymore. Cool. We're going to run it again. While it's running, clear Docker. So I'm going to go ahead and bring up that database just so you can see that I'm not making it up. There you go. There's the actual database. And finally, over here, let's go ahead and bring up Swagger. Cool. So this is running in my local one. You can see all the APIs that are available. All that documented for you. You're able to go ahead and try them out if you want. This does support a lot of metadata. If you want to do a TTL, you want to do a consistency level, you want to do any of the advanced features. We don't want to do the advanced features right now, so I'm just going to delete those. So all I'm passing it, here's what my JSON would look like to post to that API. So you give it a payload, and then just the keys. That's your primary key to be able to query that. We're going to execute it, and you can see the response there that it queried the database and got all that data for you. So similarly, let's go ahead and go over to the save. So again, delete all this extra nonsense because I don't care right now. Don't really care what the content is. So there you go, it's saved. You'll see it over here. It's in the database. Then there's even a get all. So I could do a get all, and I'm going to query that data as well. Show you that response. There's also a bunch of APIs for more advanced features like Solar. There you go. Queries the database, gets it as an array, all your data, everything in JSON. It's all mapped strongly typed to the actual objects within it. This works with user-defined types. It works with any of the functionality. I even ran it against DataStax has a project called Killer Video as the reference app. I downloaded that schema and built a full REST API off that. So that's what I used in one of my test cases to make sure it worked with all the advanced functionality. It works basically everything but counters. Because counters don't make any sense in this model. Because a counter is just an incrementing value that doesn't really fit mapping it to a persistent object. So what this functionally allows people to do is they have these APIs, or if you're not using the API version, what a lot of the developers are doing is they're storing it in an object, and then they're able to just call database.save. Give the object, persist it. Or database.get, get the object. So it basically turns it all into an ORM model for them. Cool. Any questions on that? Awesome. I have a lot of fun with it. And that's kind of the end. The only other slide is, of course, I have to throw that in there. We're always hiring. If you want to reach out, let me know. There are a couple Cassandra roles specifically that are open. I told them I'd pitch that as well. They're working. I can't talk about the details. It's a very large cluster, and they are looking for a Cassandra expert. So if you have any interest, just reach out. Let me know. Otherwise, thank you.
You said that you're doing multi-tenancy.
Correct.
Yes.
Yep.
So you just have a single cluster, or maybe a test cluster?
There are 3 clusters that I'm using. I have a prod, well, there's a couple in labs, but I'm going to ignore those. I have a prod and a stage, so basically a prod and a pre-prod. And then I have another cluster that I use for internal purposes. So if we have something that we're using, or our monitoring data goes in there, as well as we have some internal non-customer apps that we keep in that separate cluster. But as far as our high traffic ones, we put them in one large cluster.
So if a dev group is working on something, are they working in probably either
Lab.
internal or a lab?
Lab, ideally. Some groups, of course, not everyone has the lab environment fleshed out. So some of them are doing a little more of their work in stage, and we work with them if that's a requirement for them. Ideally, they do it in lab. Lab, I have everything turned on, and I don't, it's really easy, minimal access to it, and I let them do anything. It's just a complete sandbox. And then I have one that's a little more restricted, but I do make available just a wide open sandbox for them to do their dev work in.
And you've got Ansible set up so you could
Yep, so we spin up.
deploy a lab in virtual environment pretty easily.
Exactly. I still do bare metal in lab. All of it's bare metal. I made a VM once for me playing with it, but everything is bare metal. We found that the performance was so significantly different that it runs very well on the bare metal. It's very fast.
Thanks.
Yep. Yeah.
You mentioned earlier in the slides that T-Mobile is not going to cloud, and therefore your
My org within T-Mobile is not going to the
Your
cloud.
org is not.
Specifically our area, just to legally
is it-
clarify that.
Is it the security reasons? I mean, and if you were going to
Security and latency.
latency,
It's hard to compete with that latency when you have your towers that are connected to your data centers on a network. I mean, as a telecom, you had the backbone. No cloud's going to be able to compare with that latency. We're going to get directly to a handset when you're doing those core services.
You have an unfair advantage in that area.
Yeah, exactly. But yeah, the securities, there are parts of T-Mobile that use the cloud. So that's why I wanted to clarify it's our area as engineering and specifically what we're doing. So it's not that T-Mobile as a company is against cloud. It's just us.
are you using
Our
Cassandra
use cases.
in the cloud as well? Is other part of the company using Cassandra in the cloud?
There is one group, at least I know, that does cloud with Cassandra, yes.
I can see the reluctance, so I won't ask you more questions.
Especially on streaming and recorded. Any other questions?
And just so that you're aware of it, I mean, I would say at least 60, if not more percent, of DataStax customers are in the cloud. So it's not that Cassandra in the cloud isn't common, it's actually extremely common. It's just more some customers want to do things that are, get that extra oomph by being on-prem.
Yep. And there's also refer earlier to what Adrian was saying about the cloud. About reach out to you about the new offering.
Oh, yes, reach out to me about the new offering. Also, I was going to say, we're talking about the cloud. T-Mobile is effectively, I mean, it's a telecom. It's like one of the original clouds, right? I mean, that's what the telecoms were.
Yeah.
If we're just talking about the cloud as AWS, GCP, Azure. Yeah, I can say that here. Sorry. Scary for a second. Then there's, you kind of limit the sphere some, but a lot of these, like the big telecoms and stuff, I mean, they are effectively running their own cloud across the world. I mean, I always joke, it's great, in certain parts of Seattle, I get great T-Mobile service, and then I go to London, and it's even better. So, it's kind of like, what are we defining as a cloud in that sense? So they are unto themselves their own cloud. Just thought I would add that.
Mm-hmm.
Well, that sounds like part of what you've set up at T-Mobile is developers can request data or a place to store their data from you in a more cloud-like manner.
Exactly.
And so you're managing the cloud for your company internal to your org.
Exactly. If you were to go to a cloud product and you want, say, an Oracle database, you fill out a form, you get it.
Yep.
I built the exact same thing running on Oracle Rack for my customers. It's a Jenkins job. They fill it out. 30 minutes later, they get an email with credentials. It's global, distributed, Golden Gate. Everything's all set up. It's running. All they have to worry about is here's my endpoint and here's my credential. So it's cloud. It's its own version. Cool.
How do you collect payment from those customers?
We don't. It's different because they're within our org. So generally my customers are in the same VP area. So there's no bill back that I've had to deal with. I imagine, I just would have to assume there's something at the higher level that, if your area is using too many of our resources. So if there's a new org, I do have to, the management agrees that yes, it's okay.
Do you have to throttle people?
No, that hasn't been an issue. It's generally okay, just make sure that we're getting we've coordinated that yes, we are going to start doing this thing for you, and then I'm able to start doing it. It's generally yes, you can work with them, that kind of idea. And it's a quick, easy thing. It's just kind of like, let's make sure we're on the same page.
How do your leadership measure success for you guys? You must have KPIs to keep getting funded.
Yeah, so as far as the database, the main one is going to be your uptime and availability.
But not like a business benefit or customer churn?
That's going to be more, that would be the success criteria of those individual applications, right? So as the database, yeah, the distributed data systems. If you've got my system and I'm going to measure that uptime, and if I've got an outage, I've got to acknowledge that and account for that, right? But
You're an internal service offering.
yeah, exactly. It's an abstraction layer below what you're getting at there.
Probably, yeah.
What's interesting is there are use cases for Cassandra to larger enterprises that are actually tracking the usage of their infrastructure through Cassandra and actually doing the billing out of that as part of it. So it's interesting. You're talking about trying to track that, but actually they're using Cassandra to do that actual tracking also.
And if you think about the billing, like he was talking about other people at the company were using Oracle. So he's getting off of Oracle and onto Cassandra. I assume Cassandra's cheaper than Oracle, maybe? Yeah. And so
to clarify, I'm using both quite heavily. I'm not trying to, yes, newer products, yeah, a lot of it are Cassandra, but I think that is something, a very important takeaway with the products is there's reasons for both. It's neither of them are going to be the best in all scenarios. Evaluate your use case properly and evaluate which database fits your use case. And we've run into where there are some apps that we put on Cassandra that were not the best option for Cassandra. They really needed a really relational model. And it probably should have been on Oracle. Some of those being early on where we didn't know. But then I have other ones that I have one use case where they were one of our first big platforms on it, but they have a really well-defined, they're basically storing an object that has a bunch of their parameters and what they need. And they have many microservices that need to deal with that. It's kind of a session model. So they need to read and write this and needs to be available everywhere. That use case has extremely stable, extremely happy with it. They've seen far bigger than expected spikes in certain holidays and scenarios. Like, it's been really good for them. And that was one we carefully architected. It was designed properly. It's worked out really well. So we've learned different use cases. And it's a discussion when a new product comes out that you need to evaluate. Because even on the relational side, there's, like I talked about, the active-active versus active standby. That's also a discussion. You need to understand what level of consistency, what level of response time, what is the right product for your solution.
Your developer base is all Java Spring. If they start moving to Node.js or .NET Core or something, then what are you going to do?
It's mostly Java now. We do have some groups that are doing some of those other languages. And we would just adapt. The platform is more than just these. We have other systems in our portfolio, but those are the two big databases. Mm-hmm.
Well, one last question.
Yeah.
Do you have many cases where, did you say, first of all, do you have multiple regions or across data centers?
We have multiple data centers, yes.
Do you have a lot of use cases where you're writing in one and reading from another?
Absolutely.
Is that
All my use cases, Oracle and Cassandra, as an absolute given, fully redundant in all data centers, and always kept in sync. Whether my traffic can hit, so then it becomes a discussion with the application of, look, if you write to the other data center, so with Cassandra, if you write to the one in the other data center, you're looking at 50, 60 millisecond delay probably. If you do it with Oracle, you better be able to handle 5 to 10 second. So you have to have that discussion. And if the use case allows for that, great. Read and write to both data centers real time. Okay, or maybe silo it. So a lot of them are going to do that at the load balancer level, where you're keeping a cookie there so that you know that, okay, this session, now that I'm interacting with that session, I'm going to keep that going to one data center. So that, but of course, if that data center goes down or whatever, it would fail over. And then you might have some slight loss or discrepancy there for the eventual consistency, but that's better than going down. So it's a discussion, but as far as how we build the database is built the same regardless of what the application need is. It's just then we advise of, look, it is going to be in all data centers. Here's what the delays are. Here's what you need to consider to decide how you want to design and architect your application.
I asked this question because I think I haven't seen many use cases where a single object, like a single partition is being updated from one side,
Mhm.
Immediately it's required on the, it's like the use case that you mentioned, like Netflix user watching videos, for example. I mean, you'll be in one region.
Yep.
The edge cases are the ones which are transporting from one region to the other. Which
Yep.
causes you to move this traffic on the other side.
But-
It's really one side.
Yeah, so here, to give you an idea of a use case that might be that kind of idea is, what if I'm doing it asynchronously? So my user triggered some action, let's say a provisioning flow. So I signed up, it's going to take, let's say, 20 minutes to fully provision or whatever, right? So they might write something into some queue or whatever on system A. That system is now going to look up for system B, which is going to start the flow back at the beginning, and that might, system B might get routed over to data center 2. Or maybe I call an external service. Maybe I register with some external service and they have a callback. So I call them, they do a callback, because they're external to my network, they're going to come back in the global load balancer, and I'm not going to be able to tie that session at the load balancing level back to that original user. So my user might have written over here, but that one's got to come in over here. So there are some use cases that do that. When it's fully contained and we own the whole flow, then it's very easy to say, great, make sure user A is always going to go to the same data center, user B goes to this data center, we're good. But you have to understand those call flows and really understand the limitations, because all systems have limitations. You just have to design the most appropriate one and account for them. Yeah, of course. Any other questions? Yeah.
You think of like a context, like where you could pass like a context through a transaction that traces through.
Potentially, depending on how your architecture is. I mean, I think in theory, yeah, you could probably have a load balancing policy that looked at the headers or whatever.
Yeah, this transaction has been
Yeah.
done over here, next transaction do it over there.
Yeah.
Sticky, kind of like a
Yeah.
ledger.
Yeah, we do it for the individual.
Just spitballing.
Yeah, I imagine, and that's where, yeah, it's a discussion, exactly. That there are ways to account for them, and you might need different layers within your stack accounting for those, because if you did that, you would now need to teach that third-party service to add this header back in when they call back or whatever. Yep.
So my question is who is going to go have food and drink with us? Good. Who knows where Browers is? Okay, cool. 3, will the people that know where Browers is lead everybody down to Browers? And I'm going to pack, and then I will come down to Browers and make sure that the bills are paid. I promise.
Thanks, guys.
Thank you.
Thanks, Joe.